Thank you everyone for coming. My name is Chris Morgan. I'm our technical director for the OpenShift partner ecosystem at Red Hat. Would you guys rather me stand up here, or is it okay if I walk? Any strong opinions, either way? So what we're going to kind of talk about today is microservices is the big buzzword, but specifically what we want to get into is what Red Hat is doing around these concepts and the technology. We're going to talk about a product that we have called OpenShift and go into detail there. One of the things, and we've seen this message all week, when you look at disrupting business, your competition isn't your classical competition. They're probably not even in your industry, right? In fact, the Airbnb guys, he went to visit his friend in San Francisco, and he said, "Hey, man, I should be paying you for this." He said, "You absolutely should be." A business was born. And who would have thought that the largest cab company in the world owns no cabs, right? Us with our own car are the ones that we actually do this with. And we've got some surveys. First and foremost, who wants to see 50 slides with a lot of marketing? Yes, got one. If you do, you should probably leave now, because we're not going to do that today. But I do have some gratuitous things to kind of set the stage. This is a survey from PricewaterhouseCoopers that we did, where you can see, half the U.S. CEOs believe a significant competitor is going to come from outside of their industry. So the whole thing with agility and microservices and all these other kind of buzzword compliant terms that we're used to hearing are really what's driving us to get to this next generation of platform. And so, as has been probably discussed in every session, or most every session you've all joined, IT is actually evolving. Now, what I find interesting is if we start kind of on the right, the move with the application infrastructure to cloud, as you continue going down. When you look at deployment and packaging, it was initially about physical servers, then we got virtual servers, and now we've got containers, most notably based on the Docker format. And then, the move to microservices from monolithic. If any of you joined the panel yesterday, well, that may not necessarily be true in all cases, right? These things are going to continue to coexist, and it's a big part of Red Hat's business, is making sure we can help you manage both of those environments. And then, the lovely DevOps, right? We all want to be Netflix when we grow up, right? And be able to push things straight to production 200 times a day and not worry about failure. Truth of the matter is, though, it's a lot harder than that. As I like to tell people, I don't have politics in my lab, so I can do that. Unfortunately, most of you will have that when you go through and you look at the people and processes. However, we do want to try to make that easier. And in fact, we've done it, with some key customers. One in particular I'd like to bring up, it's a company called Amadeus. So Amadeus, are my Sabre guys here? Did they show up? Yeah, all right. Amadeus is kind of the Sabre, if you will, the Sabre systems of Europe. They actually manage with their reservation system all of the reservations for intercontinental hotels. They came to us, they wanted to re-platform because it was a very legacy system. And they needed something that could really handle their volume peak request, get consistency, and take advantage of every single remaining CPU possible in a containerized platform. So they came to us and were using OpenShift, and they get a lot of kind of benefits, if you will, from their operational efficiency. That was a really big reason that they went with us, is they can do the true DevOps environment and get all the benefits that they would like. So enter OpenShift. We have self-service. We do have multiple programming languages, automation, collaboration. I promised you no marketing slides. Everybody see it? All right, let's move on. So how do we do it? It should become no surprise to anyone in this room. Red Hat, we have a bit of a fondness towards open source software, to say the least. And when we look at OpenShift, it's no different. Now, I've been with Red Hat for 7 years, and what I find most exciting about OpenShift and what we're doing and what we're bringing to enterprises is we're getting back to what we do. And that is, we take best-of-breed communities, and we insert ourselves into those communities, and we take that capability and we bring it to the enterprise. So, behind Docker Incorporated, for example, and Google, we're the top contributor to both Docker and Kubernetes. So we work with all these different upstream environments, and we bring them to you. Now, we have another upstream project where we bring all these projects together called OpenShift Origin. That's our upstream and open source version of OpenShift. From OpenShift Origin, we actually create 2 commercial offerings. One is called OpenShift Enterprise, and that's where you guys take the bits, a subscription from us, and you run it yourself in your own data center. Then we also have OpenShift Online, which is our hosted service, kind of an on-demand PaaS environment, if you will. Now, what's really interesting is we're able to take advantage of both of those environments to really solidify the environment. So by taking the upstream bits and deploying them into online first, we can really harden the product, at scale. And I'll go into some of the sizes that we have currently with our online business. We take all that knowledge, we push it back upstream into Origin. Then about every 6 months or so, we actually deliver it into the enterprise product. This is a really nice model for us to get, kind of an open source 2.0 in some respects. When you look at OpenShift Online, oh, that's pretty cool. Did you see the shadow? We've deployed over 2.3 million applications on the platform, right? We've been running this thing for about 4 years with our online service. We're processing something we're most proud of is over 1 billion requests per day to those applications running in the environment. And it is a very rapid release cycle. We redeploy the entire environment every 3 weeks based on the upstream. So, we've learned a lot of best practices operationally how to do this that we're able to pass on to customers that want to run this in their data center themselves. OpenShift Enterprise, we're going to go into details here, but we've got quite a few customers that are involved with us. I think one's in the room over here to the left, right? I went to NC State, I'll not say go Hills. But we've got FICO, CA Technologies, and a lot of other good reference customers you can check out. So now let's get to the stuff that's not marketing. Enter OpenShift 3. So we've, with OpenShift, done containers since day one. Right, I mentioned we started it about 4 years ago. Our container technology was C groups isolated with SE Linux. Well, you fast forward to about 2 years ago now, and Docker came on the scene. Does everyone know what Docker is besides a stylish pant? Okay. So Docker came on the scene, and they made containers sexy. They made them portable. They made them easy. They made all these things that are real promises that we want to deliver on. And so we got onto that bandwagon. We also learned, maybe about 18 months ago now, that our previous platform didn't have everything we needed it to have. And we wanted to build it around Docker containers. So we started our own orchestration project. And then a funny thing happened. This is one of the beautiful things about working in an open source company. We were doing our work, and we got a call from some of the Google guys. They said, hey, what are you doing? I said, well, we're doing some stuff with containers. We want to orchestrate them. We think it's where everything's going. They said, hey, we'd like to show you something. So a handful of us flew out to Mountain View, and they introduced us to the Borg. Has anyone heard of the Borg besides Star Trek? Right? For those that don't know, the Borg is what Google uses to run essentially all things Google. Right? They deploy over 2 billion containers per week on this platform. 2 billion per week. Right? And what they did is they said, we're thinking about open sourcing the key components of this. And we'd love for Red Hat to be there with us and contributing and helping grow this community. And, fast forward, Kubernetes turned over a year old a couple months ago. We were there, and we started replatforming on Kubernetes ourselves. And so now, today, we have OpenShift 3 based on this new stack and best-of-breed communities. So we have a container host. Today, that container host, anyone want to guess what operating system it runs on? All right. Sort of, we'll get into that, actually. Yes, the container host is obviously Red Hat Enterprise Linux. We even have an optimized version that's just for running containers called Red Hat Atomic. And then the container API is actually kind of agnostic, if you will. So today, that container API is Docker, but we wanted something that, if for some reason that format changed or it became something different, we didn't want to have to re-platform. The container orchestration layer is Kubernetes. We support a number of languages and runtimes, and then we actually drive the developer experience. when you look at the application services we support, everything in blue are the runtimes and frameworks that we actually ship. I need to update this slide because obviously recently hell froze over and Microsoft and Red Hat formed an alliance. And we will be shipping .NET for those of you that didn't realize hell froze over. And we're going to take this, and that's what we have. Now, another interesting thing about going to Docker is now we actually have access to anything on Docker Hub. Right? Now, I wouldn't recommend you download anything random from Docker Hub and run it unless you want to bring down your entire cluster. However, you can do it, right? We support anything that's in the Docker format, and we support it natively. And it really just helped us grow the ecosystem when we look at that. We also have, do we have any JBoss users in the room? Got to be a few, man. This is a monitoring conference, right? All right, cool. All the JBoss suite actually runs on top of OpenShift. It's been containerized. So you get all the ease and management and other kind of cool things. Something that's coming in the fall is we acquired a company called Feed Henry. It's our Red Hat mobile platform. That too is being migrated to OpenShift. So we'll have a really nice complete story all the way to a backend, mobile backend as a service capability as well. We also have something called OpenShift Commons. This is kind of our community around the community. It is not a foundation. It is free to join. There's special interest groups. It's made up of customers, partners, and generally anyone who has an interest in doing something with OpenShift. What are the benefits for developers? You know, at the end of the day, it's a DevOps platform. Developers want to write Angry Birds. They don't want to do anything but write their code, and they want to pick the language they want to write it in. We provide that, right? We provide that, and we integrate it with the source code and do the injection and the other pieces that they need to make that happen. For IT operations, you know, that choice can be scary, so we want to give them a means of control. And by bringing those together, by allowing choice and flexibility for the developer, but still providing the control the operations team needs, this is what we're delivering with OpenShift. So now the fun slide before we get to, well, does anybody want to see a demo? Or would you rather death by PowerPoint? Yes! Where's my boy? You can go ahead and start getting set up. I'm going to go through this. So this is the architecture. Now, I mentioned that we used Kubernetes, which was outsourced by, oh, you can't unplug it yet.
Oh. Sorry.
I mentioned that we used Kubernetes that was open sourced by Google. Now, what's interesting is, you know, Google said to the world, this is how we do microservices, right? These are the patterns we use. This is what we do and how we do it. I mean, you know, it's an interesting question. When's the last time Google search went down? Anybody know? It's a trick question. It never has, right? It's pretty interesting. And it's because they have this highly fault-tolerant environment that they've designed with the Borg, and now they've made that available to you via Kubernetes. However, they also said, oh, well, you know, people are going to run this on Google Compute Engine. Well, maybe. But so one thing when you look at it that we had to add with OpenShift, if you look down at the bottom, it's that service layer. So the service layer is essentially how all the what we call the master, and the master cluster, if you will, the control where the APIs are, actually manages all the different nodes in the environment. The one we switch is Open vSwitch, but we can work with any SDN provider. We have a couple of preferred partners with Juniper and UODG, for example, that have already done integrations for that. When you look at the top, another thing Google presumed is, oh, you'll use Google's load balancer to access this stuff externally. Maybe not. So we also wrote an external routing layer. That routing layer today is based on HA proxy. And what's interesting, and we're doing this with several of the components, is the routing layer actually runs in OpenShift. And you may think, all right, Chris, that's not a big deal. Well, it is, because now that routing layer is highly fault tolerant. It's able to take advantage of Kubernetes and all the health monitoring and the things that it does with its intent. Another key concept to understand is that of a pod. So a pod is one or more containers, right? Now, typically, you may only have one container in a pod, but if there are things that you always want to version together, you'll usually have multiple containers. But when I mentioned a container API abstraction, that's what a pod gives us, right? You don't do things against containers, you do them against the pod. So if I need to share storage between pods, for example, or anything that needs to be in the same namespace, I'll utilize a pod. Another piece that we had to add was the concept of persistent storage. Again, I mentioned this at the panel, but 12-factor apps, they're really cool. I love cool stuff too, but I had one CIO tell me, he said, Chris, I've got 8,000 custom applications. I can maybe move 10 of them to be fully stateless. What do I do with my other 7,990 apps where I want to take advantage of containers? Enter the capability to get this persistent storage back in. Today that works with iSCSI, it works with Cinder, works with Ceph, works with the AWS backend, the Google backend, pretty much all the major block storage capability that you have out there. We also deploy our own registry because we're doing a lot of work, as you're going to see in the demo. When we push code, right, we have to have our own private registry. You can actually populate that with anything you want, so you get some control there. And then when we look over to the API capabilities that we had to add authentication to the actual API calls, because that was not there with Kubernetes either when they make the call. The data store is actually just etcd. If any of you have heard of etcd, it's a technology there. The scheduler is the main built-in scheduler. And what's really interesting is etcd and the scheduler work together with something called labels. So in the kind of OpenShift Kubernetes world, policy is determined by labels. You can label anything, right? If you want to do a query against something, you slap a label on it. And it all of a sudden allows you to do some really interesting affinity and even anti-affinity deployment scenarios in the environment without you having to think about it, right? Because with etcd, it's understanding the state of the entire environment. So for example, maybe I want my Mongo to always have 4 nodes, right? Always want to have 4 pods running. And maybe they have a label of QA. Kubernetes will understand, based on what's in etcd, all right, 2 of these died. You told me I have to have 4. Let me find somewhere to put it. And it just does it, right? It's a very highly fault-tolerant capability that it puts it in there. And so, with that, we only had 40 minutes, and I really wanted to get to kind of a demo. So what we want to show, we are going to show this, right? All right. Damn, son. That's right. Something else we had to add. So every vendor you talk to is going to say, hey, we can run Docker containers, right? Every one of them. I know you guys have sat in other pitches, and that is absolutely true. In fact, I dare say I could take a couple of you guys, we go sit down, write a few bash scripts. We, too, can run Docker containers. However, how do I get my custom code into that container and drive the app lifecycle? So something that we had to create is a concept called source to image, where we do the injection of your source code into the image itself. What we've set up and some of the integration work we've done with the good folks at AppDynamics is at the time of deployment, there's actually a source to image deployment of the agent along with the source code. So your actual application is immediately monitored at time of deployment from the source. We're going to show utilizing that to create all the back-end images and then the actual application. And then what we want to do is, okay, now the developer is taken over, and we're going to show the developer actually deploying an application. So with that, you can now take it apart. We're going to show a demo.
They're going to see if it displays first.
Yes. So while he's working on that, it's probably a good opportunity. Do we have any questions in the interim? Don't be shy. I have stickers. Oh, there's a question at the back. If you'd wait for the mic. Oh. Well, you should ask it on the mic. No questions? It can't be that clear. All right. Yeah, we got a mic here.
How would you compare this to some other open source initiative like Cloud Foundry?
Well, oh, you mean the Dell project?
Yeah.
Y'all like that?
Really a tough question.
Right. So, when I look at it, I go back to how we utilize community. Less than 20% of the code for OpenShift comes from Red Hat. If you look at Cloud Foundry, a majority of their code now comes from one vendor. You know, and they kind of went their own route. It is open source, to be fair, but you know, how many of you in here have ever said, hey, I really want to write a garden container? Right, anybody? One, anybody? Right, how many of you have said, hey, I have to write a Docker container? Right. You know, what we do and what we've done, how I would compare it is we let the community decide. It's what we do. We've done it for 20 years, right? Is, you know, Red Hat says, hey, these are great communities, and we insert ourselves. And so that's really kind of how we address that. You got it?
Yep.
All right, cool.
All right, so thanks, Chris. So essentially, you know, the whole source to image thing process involves taking a base builder image, either from the open source world in Wildfly or from the real world with JBoss EAP. And we've done both. So if you go to this GitHub repository, STI Wildfly, which is forked from the OpenShift Wildfly repository, you'll find that there are two directories. One is for 8.1 Wildfly, and in that you can see there is a Docker file for Wildfly and for EAP as well. And you can see that the base image that we used here is from RHEL. So what I'm going to do is I'm going to switch gears and go to a terminal and show you how this particular thing works. Can you guys see the screen large enough? Or should I make it bigger? Is that good? Yeah, okay.
Type a clear command.
So I've just, to make it simpler, I've added a bunch of commands. So the first step obviously is to clone this GitHub. I'm looking at the tasks for the operator, and then we'll switch over to the developer. So the operator's first task is to take a base builder image, such as the one that we used in the Docker file, and he can change it if he wants, and run the script. And basically, first thing he's going to do is clone the repository. So he's cloning into the Wildfly repository. The second step he's going to do is build the enhanced builder image with the AppDynamics agent in it. And that essentially will dynamically pull down the AppDynamics agent from our download site and add it to, and create a brand new Docker image. So that's what's happening here.
So if I could summarize sort of what he's done here is we obviously ship commercial JBoss enterprise application platform, and what AppDynamics team has done is actually now said, hey, here's how you can enable that to automatically be monitored with AppDynamics. This image he's created, as he finishes up here, is going to be made available now to the developer to do their new app command with their source code and deploy it into this particular image that's already set up to be monitored. So think of it as the operations guy is going to, or gal, as the case may be, is going to make available, an image that's EAP monitored with AppDynamics. And that can be the only one that's shown in the catalog, right? You wouldn't even have to show the default one. The ops guy has complete control there.
Right. So now the next step is, so the enhanced builder image is now ready. So now the operator is going to make a application image on behalf of his developer. So that's the S2I build script that's running. As you can see, at this point, you're actually customizing everything that, it binds your application to a particular controller, to a particular account, and you provided the account access key, the controller host, and the controller port, and all that stuff, SSL enabled, false, etc. So this is where the application image is being built based off of the enhanced builder image.
So I'd also like to point out these use cases are actually driven by a joint customer that we both have. So it wasn't Pronta and I, sitting at a bar having bourbon say, hey, we should do this. This is actually driven through actual customer use cases and how they expected to use the product. So this can take a little bit of time the first time, as you can imagine, as any initial Docker build does. Do you want to maybe switch over to the OpenShift console and show kind of some stuff there? Just again, for the sake of time. As any of you that have used Docker, the initial build always takes a while. It's the subsequent ones that are literally seconds, if not less than a second, when you do it because of the layering and all the other cool stuff that it does when you do a build.
And just to show you, like take out the baked cake.
You lost it.
And
You got in the screen.
oh, did I? Huh. Try it again.
That didn't work. Yes, I need the mic first, though. Where's the mic? No, I was told we got to do it. I need the microphone. I got a question. Oh, it's all right. Here you go.
No, in the application image,
Uh-oh.
the application image is built in the AppDynamics controller. If you have to switch the application AppDynamics controller, you have to change the configuration file or
So there's two ways you can do it. Oh,
Because the mic was off.
oh, he's got to hit a button. Well, he's still right here. Is the mic on? All right, go for it. Try to get.
Can you hear? Okay. Yes. So if you can build the application with the AppDynamics controller properties already built in, if you change anything in your environment, how do you change it? You have to rebuild.
So there's two ways to do it. We did this particular configuration because of the customer requirement, but you'll also notice that he passed in a lot of -e flags. Everything's an environment variable, so you can change all of that. We just wanted it to be, for this particular customer scenario, they wanted to know it was going. They didn't want the developer to have to know which controller to go to. So they've created an image that's pre-configured.
Yeah. So now the application image is ready. Now you can decide that, hey, maybe I want to actually look at, see if it's actually created. You can see that this was created 2 minutes ago. And then you have the choice of logging into Docker and pushing the image to a place of your choice, or you could even publish it on the Red Hat container registry. And in this case, I'll say yes. So just pushing to Docker on my account so that my developers can just pull it. And yeah, so the next step is now the developer would take that image and basically deploy his application into OpenShift. So that's what I'm going to show you next. So meanwhile, we see that I have a pre-baked cake here in the interest of time. So the app that you deploy to OpenShift now is visible, and you can see all the nodes and tiers and backends that you would normally expect. And there's the Docker push is done, and now I would basically log into OpenShift. Oops, I gave away my password.
OpenShift does not endorse default as a password.
So I'm just going to create a new project called AppSphere demo. And well, I didn't delete it, but it's okay. But you get the idea. So now I can just deploy the app, and once I've done that, it'll show. So that's the
Show them
basics.
the console where it's already.
Oh, right, yeah. So the console, my app will probably show up as in progress, but the, hang on. Yeah, there you go. So that app is still being deployed. This is a pre-baked app that I showed you that has already been deployed, is running, and this console is actually looking at that particular thing. So that's the demo. Any questions? All right. Thank you.
Oh, you got a question there.
So we just noticed we're actually looking at the code while you're putting it out. So I think in the example, you're showing putting the source code onto the container, then building it with the binaries.
Take a moment.
Wouldn't it be preferred to potentially like build the artifact and then put it onto the container? So when you're downloading that actual container, you're not downloading source and binaries? Or is there a specific reason why it was implemented in that fashion?
So
Or
we
is it specific?
we support both binary deployments and from source, right? Given it's a kind of a DevOpsy kind of thing, you know, building from source is what a lot of folks do, especially as they want to move into that pure DevOps, or even better yet, a lot of folks aren't even doing DevOps, they're just going straight CD, right? But we realize what I was mentioning before, that some habits die hard. So you would also be able to use a binary artifact and push that out instead. Right, you can say this is the blessed final thing we want to push, and you can use that also. This was just the customer requirement that they wanted to be pushing from source all the time. Good question, though. Is it a real one this time? All right.
Question is there a reason, so OpenShift is targeted for RHEL 7, right? For the most part.
I mean, it runs on RHEL 7.
It runs on, that's what I'm saying.
Yeah,
So is there a reason there wasn't a support approach for actually putting it on RHEL 6? I know he's going to ask that as there's large infrastructures out there running RHEL 6, making the jump to RHEL 7, even RHEL
Sure.
7 Atomic is not exactly an easy jump. And then maintaining both in the data center.
So Docker wasn't in RHEL 6. The version of Docker you need is not in RHEL 6. That's the primary reason. The other thing is it's not. Right, the version that we need for this. It's a way more recent version, right? The other thing is you really don't worry about the RHEL part here because it's included with the subscription. It's an embedded component, more or less, right? So even the shops we have, and we obviously have a lot of them that are using both RHEL 5 and RHEL 6, this doesn't bother them because, again, it's embedded in it, and they're going to move there anyway. This is just the first app that's on RHEL 7 as far as they're concerned. It is. So we use Ansible as our installer. Big shock since we acquired them, obviously. So they handle all of our install. And in fact, with 3.1 that came out a couple weeks ago, it'll actually do the high availability install as well. Good question. Any other questions? No more questions? I have more stickers. I'll take it. There you go.
Architecture-wise, what's the difference between Atomic versus RHEL 7? Is it a memory footprint or Atomic?
Oh, so it's so funny. I got to kind of pick on our own marketing just a little bit. RHEL Atomic is just an install of RHEL. It's an install type of RHEL, right? It utilizes OS tree. It's not a separate SKU. So if you have a RHEL 7 SKU, you can install RHEL Atomic. It's included. It's just not in Anaconda for those of you that have actually installed Red Hat Enterprise Linux. They're putting it in Anaconda so it'll be a selector. But because it is so different underneath by utilizing OS tree mostly, that's why it looks like it's a different thing. But it's RHEL 7. In our case, we work with Atomic or RHEL 7. That's it? Y'all are a quiet crowd. I'm not even between you and beer. There's got to be one more question. Awesome. Well, I think we're on time, right? Okay, cool. All right. Very good. Another one? What?
No, sorry, I was just going to add, if anyone wants to see a demo, we put up this on the AppDynamics Vimeo channel.
Oh, okay.
If anyone wants to see a bit more detail.
Oh, yeah. So definitely take a look at that. And for those of you who want to see something cool, again, it's still so new, I like to talk about it, but the Microsoft partnership, there's a video showing deploying a .NET application into OpenShift. And it's on Red Hat Enterprise Linux, which is cracking me up if you actually see it. So, there's just a lot of goodness going on right now to make it easy. And, I just can't stress enough, our focus is both greenfield with all the next-gen stuff, but we realize you have a lot of legacy apps, that you want to take advantage of containers and the goodness and the multi-tenancy, right? Like we get from a lot of customers is, hey, I want containers. Why? Well, I don't want 12 Apache VMs. I can do it with 12 Apache containers on one VM, or better yet, back on a bare metal machine, right? Because containers are multi-tenant in the OS itself, inside of the kernel. So you're able to use the compute almost directly. So that's some stuff that we're seeing as well. Cool. Well, with that, I'll let you guys go. Thank you for your time. And if there are any questions, I'm around the rest of the day.